inside of a golf ball. We have the external, and then the internal center is a little bit different. The very center is where you're going to find your macrophages. The outside is where you're going to find your lymphocytes. So these little germinal centers are actually little balls, so to speak, cells arranged in balls, spherical fashion. So you can see the cortex here. Here's kind of the base of the cortex. This will be the medulla. Here's that lymph vessel, or whatever it happens to be. I think it's a lymph vessel. You have the capsule over here, the capsule being dense, irregular connective tissue, and then you have other connective tissue to the outside. This is the hilus, the triangular piece, and then you can see the trabecula going deeper into the node. So you can see a lot of different hyli, if you want to use that. There's one, there's one, there's one, there's one. And what those are now, if you remember the kidney, the arteries and the veins, and in this case the lymph vessels, enter and leave the node at those places. In the kidney, you recognize it's bean-shaped. The hilus there, you have the renal artery, the renal vein, and the ureter coming out of there. So the hilus just simply means this triangle, this small triangle here, where those vessels and such enter and leave. Whole lymph node here, basically you can see the center of these on the most part. You can see the cortex and you can see the medulla fairly easily. You have your connective tissue here. There's going to be some loose areolar tissue and some dense irregular tissue. There's going to be some fat over in here. This is the muscular artery going all the way through here. The wall here, if you look at that, you would find the smooth muscle cells. Like I said this morning, this had a bend in it when they cut it. So even at this level, you get to the capsule, you can see a clear space underneath. That's really what's going to be the subcapsular space. Looking at this one now, the same thing. The germinal centers are here and here. Go to the capsule, your dense irregular connective tissue. You see a little bit of it peel off and go into the hilus. When it gets inside the hilus and goes inward, that's where you start calling it a trabecula. So it's capsule all the way to here, and then it becomes the trabecula as it moves in. This space underneath the capsule very well may be an artifact, a shrinkage artifact, because when you put these things in ethanol or acetone, they will shrink down. Some people think it's artifact. I don't care whether it is or not, but for you, it is the only lymphatic structure, really, nodular tissue, that has this space between the capsule and the organ itself. So it makes it a good piece to use for reference and to guide you through this. Because the germinal centers, the middle of them may or may not look the same to you. Go up with magnification again. This is my favorite picture of the lymph nodes. Here you have the dense irregular connective tissue. There is some white fat in here, so you do have to be aware of that. This is actually what they call the subcapsular space. Here you have loose areolar connective tissue. There's a little loose areolar connective tissue here. And remember your rule, if you see fat, you generally see loose areolar connective tissue in the same field. Here you have your lymphocytes. Here you have most of your macrophages, even though it's a combination of both. It's just there's more lymphocytes here, more macrophages here. So the pink things that are on the inside here are actually the lymphocytes. The dark things up here are the lymphocytes. So you have each cell type in both locations. It's just their numbers change from inside to outside. The inside of the germinal center, again here, macrophages, lymphocytes, all of those things, and here you do have blood vessels that you could be asked to identify. Nothing real big with it, but I wouldn't feel comfortable asking a cell question at this point. You may or may not know that this is lymph node, but really the big difference between the lymph node and the spleen is that in these germinal centers, in the center, you're going to see red cells and you're going to see hemosiderin. You're not going to see that in your lymph nodes. Okay. This is just the special or the stain of the trabecula coming off of the capsule. So here you can see the triangle nature of that hilus, and then the dark things are the reticular fibers secreted by, in your book they call them reticular cells. I just call everything fibroblasts like that because that's what they are. Because the fibroblast secretes the reticular cells, the elastin, and the collagen. So why change names? This is the spleen, and your big point of reference here is on the surface. Notice that the capsule is very firmly attached. There is no shrinkage on these, and it's attached quite firmly. You do have trabeculae in here in all kinds of different areas. Even though these are still germinal centers, with the spleen they changed the name to white pulp and red pulp. We will use that terminology, but these germinal centers are actually the white pulp. Again, it's because of the white blood cells. The white blood cells their nuclei are basophilic, so that's the reasoning behind the name. This picture is pretty good as well. You can see the capsule and see how the capsule is associated with the trabeculae. Some come from the edge, some are coming from the other side, so you'll have cross section, long section, tangential section on this one. Everything that is blue is going to be the connective tissue associated with the trabeculae. The white pulp is not stained specifically. You can see the areas where the germinal centers are supposed to be, but this is much thinner, and this slide shows you the red pulp. The red pulp is the intervening areas that surround and go between areas of white pulp. So all of this is red pulp. The white pulp is just a little nodule. This will be your medullary cords. Again, these are the structures that are like the radiator in your room. These things are the trabeculae. This is where a lot of cells move back and forth into the system. Right here is one of those in cross section. You can see all of your cells, or quite a few of them, becoming amoeboid and working through those areas. So again, you have the macrophages as the clear ones, the lymphocytes as being the dark ones. And this is a resin section, so things are really, really thin here. So much more clear. Trabecula, red pulp, white pulp around here, white pulp around here, showing you the reticular fibers in the system. The more reddish cells on this one are the macrophages, the dark ones are still the lymphocytes. It's a little bit different staining situation because we wanted to show the reticular fibers. Now if you get up here, there's thin cells, that's going to be your fibroblast again. Little triangle piece right here, that is a fibroblast. This one you're sick of. I'm sick of it. You've seen it a lot the last month and a half. Red cells, macrophages, hemosiderin, lymphocytes down here. This is the only place you're going to find that in the lymphatic organ is going to be the spleen. So definitely this separates spleen from lymph node. Germinal center of a thymus. Hassel's corpuscle is in the middle, which are really just layers of old epithelial cells. See the lymphocytes over here. I don't know why it doesn't stain completely all the way around, but the macrophages are going to be in this centerpiece here. Showing the lobation, shows you the pink regions here that are the Hassel's corpuscles. You'll be able to go up and see those. You can see some fat here, white fat around here, then your lucerolar connective tissue. Notice that the thymus doesn't have much of a capsule. Nothing like the lymph node or the spleen. So of the three, the spleen has the more intense capsule. It has the stronger capsule to it. Here again, the white area is washed out because the light was too bright when they snapped the picture. But if you go away from that, you can see the pink areas where the Hassel's corpuscles are. There can be hundreds of them in any given field of view. You're going to have blood vessels scattered throughout as well. Move up in magnification. Blood cells here because you can see white cells amongst the red cells. Here you have more blood cells. These are the Hassel's corpuscles, and the corpuscles will have some kind of cellular component in the middle, and these are the cells responsible for the transfer of a regular lymphocyte into a T lymphocyte. But you can see that a lot of these Hassel's corpuscles in the field here, they can be one cell or they can be huge conglomerate things. going across. The rest of the cells here are going to be your lymphocytes and your macrophages. Higher magnification view here, simply lymphocytes and macrophages, just a different stain. Okay, that's lymphatic. I'm going to move forward into the integumentary system. And as I said, the other group, getting through this series of slides, this is your goal by next Friday. I'd like you to have you done through the integumentary system if you can get there, because then when you get back, we will do the upper reaches of the digestive system, and then we'll have a quiz. So that first part of the digestive system will be there too. Again, thick skin, everything you learned before, a lot of review here. You can see the dermal papillae, you can see the epidermal ridges, you can draw your imaginary line to see the dermal papillae, which is where you're going to have your lamina propria. You can see your reticular layer with more more larger sized collagen fibers. Here is a good example. Somebody asked once upon a time, what do these glands look like? Do we really have to look at them? Well, here is a tubuloalveolar acinar gland. It kind of looks like a tree here. Okay, so that's kind of neat. This is in areas of the groin, in areas in the armpit. Thick, viscous, mucousy type stuff comes out of here. Smelly stuff if you want, if the bacteria starts to chew on it. So you can tell that it's white because it's got mucus in it. If it would have been a serous type gland, you would have had stain here. It would have been basophilic, but it's not. So here, just a showing of thick skin. We're going to go up in magnification to see it. Watch this area right here. That is actually a duct from a sweat gland that's somewhere down the road. I don't know exactly where it is. This little stitch is the duct, so you should be able to find the simple cuboidal epithelium of the duct. But here again, know your layers. You know, if you didn't learn the layers of the squamous epithelium before, now is the time to learn those. Go to the basement membrane. You have the stratum germinativum. The cells in between or above them is going to be the stratum spinosum. The dark layer is the stratum granulosum. The clear layer is the stratum lucidum, and the stratum corneum is the top. Then you can see the loose areolar connective tissue up here if you draw your imaginary line in the dermal papillae. If you're looking for Meissner's corpuscles, they live up in these dermal papillae. You're going to be looking for those nervous structures at this point. The large corpuscle of Vater Pacini will be somewhere way down in here. They're so large, sometimes you don't have to put them on the microscope. But again, there's the loose areolar connective tissue, dense irregular connective tissue. Higher magnification, upside down. Basement membrane would be down in here somewhere, so this is the stratum germinativum. Here's the loose areolar connective tissue of the lamina propria. So stratum germinativum, stratum spinosum, stratum granulosum. It's more than one cell thick because this is kind of resiny, paraffin-y, a paraffin section, so you have a fold in here, so you're getting more than one cell. Here you have the stratum lucidum, and if you look here, you can almost see the layering, or the single layer of the simple cuboidal epithelium. So this and this is the simple coiled tubular duct as it passes from top to bottom. Just a thick, really thick, large section. About the thickness of the pointer is the epidermis with all its layers. The pigmented layer right next to it is the lamina propria, loose areolar connective tissue. Then you go into your dense irregular connective tissue of the reticular layer. Then you're into the hypodermis because there's white adipose fat, and down in here you would have a sweat gland or sudoriferous gland, so you would see simple and stratified cuboidal epithelium. So this basically defines the layering for that. Thin skin is the same. It basically has all of the layers. It doesn't have to have all of the layers, but it can. Stratum germinativum is down here. Let's just go through the layers again. Stratum germinativum is down in here. It's the stratum lucidum. Now your stratum granulosum is just one cell thick. Stratum lucidum is this layer up here. The corneum is that layer that is sloughing off. Now this tells you that you're on the external of the body, because the internal of the body you don't have the stratum corneum. You won't have this arrangement there. With the lamina propria again, loose areolar connective tissue going into the dense irregular connective tissue. You can get fibroblasts again and things like that. We could talk layers, we could talk cells, we could talk all kinds of different things off of this section. Just some EM pictures, and as I told those, this actually is stereo pair, and if you look at them kind of this way, see this region right here is the same region that's up here. If you cross your eyes the right way and you turn your head just right, you can get this in 3 dimensions. That's what stereo pairs are useful for, but it just shows you the stratum germinativum and then the layers going up. This is the stratum granulosum, and this one does not have a stratum lucidum because this is the cornified layer. That's what the granulosum is here. This is a $60 million slide. Tons and tons and tons and tons of questions can come off the section like this. So when you get into the section of the integument, where it's the scalp or what have you, learn all the structures. Because I'm going to hold you for the layering of the epidermis, the layering of the dermis, the stratum, or I mean the dermal papillae, the epidermal ridges, the lamina propria, the loose areolar connective tissue, the dense irregular connective tissue, the hair follicles, shafts if they're present, the sebaceous glands which are present here. You can see where they would be dumping into the follicle there. The cuboidal epithelium of the sweat glands and the ducts, the hair roots and bulbs. We could also talk about fibroblasts, mast cells, collagen fibers. So there's 1,000 things I can put on this. So when you get to that, do spend a little bit of time looking at the various structures. Here we have the skin that's actually stained with a red. It's a red dye, but it's shown with polarizing light. So you'll be able to see some crystalline nature to this as you go up in magnification. But what I want to point out is here you know where the dermal papillae are, and you know where the epidermal ridges are. You know where all of that stuff is. Here's a duct. There's a duct going through. But you see these little structures going deeper into the dermis. These are the structures that are called the interpapillary pegs. And in areas where you have a severe amount of stress, shearing stress, like you're opening a stuck jar off of a pickle jar, those types of areas where you're going to put most stress on the body, you will have these, and there are little structures that help to keep the skin attached a little more firmly. So say for example, we told you once upon a time that a 300-mile-an-hour wind will peel most of the skin off of you. The skin on the palms of the hands won't be going with it. You got to have more force than that. But the skin on the face or the neck or the back will surely be stripped with that much wind. But these are the reasons why that happens. So then you have your loose areolar connective tissue, you have your dense irregular connective tissue. Higher magnification view, there's a picture of the pegs which proves to you that this is stratified squamous epithelium. You can see the adjacent nature of those cells. This is one of the dermal papillae, just about ready to open if you'd section a little bit more. Here's one of those ducts. Here's a dermal papilla, and this is the exact location where you're going to find the Meissner's corpuscles, and that's what I want to point out yet today. Just a little area of the dermis here. You can see sweat glands. You can see the cuboidal nature of those. Same section. Here's the Meissner's corpuscle. Now take a look at that, and notice that these things are layered in appearance. Whether across or along section, you're going to see these neurons, or basically this is a modified dendrite. You're going to see the cells stacked here. And what you're seeing stacked is the Schwann cells. But here you're going to have, this is a nervous structure which will send, it's modified dendrite, it will send the information to the dorsal root ganglion from the skin and then into the spinal cord. So it's a great section to say where would this go next from this. If this is a modified dendrite, what's the next structure? Neuron cell body. Where's the neuron cell body found? Dorsal root ganglion. You should know that without having to see the picture. But that is a pretty good Meissner's corpuscle. This large structure here is a corpuscle of Vatra Pacini. Sometimes they call them Pacinian corpuscles. He was a priest, interested in science, kind of like Gregor Mendel. Looked like the laminated tree rings. You know, some people in the past have gotten this mixed up with an osteon, just because of that laminar nature. Here you have your dense, irregular connective tissue. This is actually a sweat gland. Over here, stained a little bit differently. And then up here you have nerves. There's the axons here, and then here's the axons, here's the axons, and then you have a little bit of the connective. You don't have the great big nerve like we showed before, but you have the ones. This tells you you're pretty close to the periphery of the body, and this is actually in the dermis of the skin. Looking for Pacinian corpuscles. The dermis of the skin or the mesenteries is about the only place you're going to find them. Deal with pressure. Pretty picture there. I like the purple. But today we're supposed to wear purple, so I don't have purple. I don't own anything purple, so I'll show you a purple slide. Hair follicles, hair roots, hair bulbs. You can see the pigment down here, and you can tell that the hair shaft is ultimately going to be black, just because of the amount of melanin there. You have the dense irregular connective tissue down here, dense irregular all over the place, but you just have these follicles. Now, note in this, we have this little ladder appearance. In section, the hair shaft has these little rungs of the ladder. In your sections, most of them will be a yellow-green, and most of them you'll see in cross-section. Oftentimes, when you get to sectioning these things, if you use a dull knife, the blade will catch on it and it will pull the hair out of the follicle, so you have nothing to show when you're finished. So if you want to do skin with hair in it, you've got to have brand new, freshly sharpened knives in order to get the hair follicle or the hair shaft to stay in the follicle. Higher magnification view. Again, we have stratified squamous epithelium. There's the hair root and the bulb system. This is a little bit of smooth muscle for the erector pili muscle. This is your connective tissue, which will be dense, irregular connective tissue. And now you can see melanin in the upper cells. The melanin will go into the cells or beyond the cells, which are going to be pigmenting your hair. So this one's going to be a dark-haired individual who this section came from. Now we have a vein down here, so there's all kinds of things you can look for. That's it. Anybody got a question or want to see anything?